Good afternoon and welcome to this session on Thursday afternoon at the MGM on life-saving early warning systems and mitigation for climate disasters. Every year and every day, citizens around the world are impacted more and more by climate change. And according to the Inter-American Development Bank, since 1970, there's been an increase in climatological disasters six times greater. Unbelievable. Actually, I should start by saying this session will be in English and in Spanish. So if you want headsets, I should have said that at the beginning, if you want headsets, they're in the back. So if you want translation to English from Spanish or Spanish to English, they're in the back. Today we're going to talk about both climate mitigation and climate adaptation. It's how we use technology to help be prepared and also to help respond to natural disasters, as well as how we use technology to be able to reduce carbon emissions, and both go hand in hand. I'm joined today by a distinguished panel. First, it's my pleasure to introduce Rodrigo Bellissoni, who joins us from Minas Gerais, Brazil. He's a public policy specialist for the Center for Territorial Intelligence and a specialist in public policy and land management. I'm also joined by Melissa Rivera. Ella viene de Panamá y es la directora del Centro de Operaciones de Emergencia del Sistema Nacional de Protección Civil. Ella es gestora y también ella maneja la relación de los colaboradores internacionales en todo lo que es apoyo de desastres en Panamá. Y es gestora de desastre y emergencia, certificado en Japón y ha pasado mucho tiempo en Japón. Y también Camila Saad, que forma parte del equipo de Camila Saad, that forms part of the Disaster Preparedness and Response Team for Latin America, Canada, and the Caribbean. Actually, she's the leader of that initiative. Before joining AWS, Camila worked for the Bill and Melinda Gates Foundation and McKinsey and has a master's from Harvard University. Today, we're going to start off the discussion with a video about Selo Verde, which is a project in Brazil, in the Brazil state of Pará. And then Rodrigo will share some thoughts and comments following the video. And then we'll move on to a video showing the early warning system in Panama that's being implemented by Senaproc. And then we'll chat a little bit with Camila about the rest of what we're doing in Latin America. So let's roll the Selo Verde video.
Modern, transparent and free, the platform Selo Verde is the biggest ally of those who wish to demonstrate or verify that the agricultural products in Pará comply with environmental legislation and are not associated with deforestation. The platform, made available by State Secretariat for the Environment and Sustainability, enables agricultural producers to check if their property is in compliance with the Brazilian Forest Code and proceed to regularize in case of non-compliance. And for the government, it allows the monitoring and assessment of sustainable development policies and the fight against illegal deforestation. Selo Verde provides transparency and traceability in the soy and cattle production chains across the entire state territory, allowing the identification of the majority that produces without deforesting and the minority that deforests or has socio-environmental irregularities through the integration of public data and satellite monitoring. With it, you'll also find information about indigenous and conserved areas, environmental embargoes, or labor analogous to slavery, and have immediate access to the most up-to-date environmental status on all rural properties registered in the Rural Environmental Registry, CAR, including for the supplying of cattle in the Amazon region according to the criteria set by the Federal Prosecution Service. And do you know how Selo Verde achieves all of this? Using cutting-edge technology, integrating artificial intelligence, high-resolution images, and big data processing in the Amazon Web Services cloud. Selo Verde 2.2 also brings Mapia 2.0, a high-resolution land use map, machine learning, and much more. But the best thing is that despite all this technology, the platform is very easy to use. Have a look. Just enter the CAR code of any rural property registered in the Rural Environmental Registry to access the socio-environmental diagnosis and compliance with the criteria for supplying cattle in the Amazon. In addition to that, you can also see the permanent preservation areas, fragments of native vegetation, eventual occurrence of deforestation, and a lot of other relevant information. Did you find the property you wanted and would like to use the information available? Do not worry. The platform allows you to generate and print a detailed report to demonstrate that the agricultural production on the property has no connection with deforestation or socio-environmental irregularities, for example. You can also go straight to the map. To get to the information, just click on this document, for example, and you get all the details about the subject of your choice. It is also possible to zoom in by clicking on the magnifying glass and browsing an interactive map that covers all properties in Pará. And this way, access the socio-environmental diagnosis of any property in the state. And the agricultural producer can also be at ease. Selo Verde protects personal data and the commercial transactions of producers. And it also helps in the regularization, reinsertion in the market, and engagement to achieve environmental compliance when environmental issues are detected. Creating transparency, adding value to agricultural production, expanding access to national and international markets. And the best thing is, combining science, technology, and environmental protection. Selo Verde Pará. Science and technology in support of environmental sustainability of agriculture and livestock farming.
So I had the opportunity to pass by the Sustainability Pavilion this week and actually firsthand dive right into the platform, and it is very easy and very cool to see. Share a little bit with us, Rodrigo, of some more details.
Sure. We've just seen an example of how science and technology can shape better public policies and also more effective decision-making and enforcement, right? In addition to the problem of deforestation we have in Brazil, there's this growing concern regarding forest fires in the states, in Brazilian states, right? So climate change has intensified these events and require enhanced public policies and also territorial intelligence, like this example we've just seen on the screen. And so to address this problem of caused by climate change, intensification of fires there, we also developed another system in Brazil, which is a fire spread prediction system for the highly fire-prone Brazilian savanna, right? And basically this system merges hot pixels with satellite data to create maps with fuel loads, vegetation humidity, and fire probability, right? It's being used there by conservation units management and by the public sector to make better decisions regarding controlling wildfires in the country. Yeah.
Incredible, really, and also relevant for many countries, not just Brazil. So it's great that you're pioneering that. Now let's roll a little bit further north in Latin America to Panama, and let's watch the Sinoproc video.
El río Juan Díaz presenta múltiples afectaciones de inundaciones a lo largo de años.
El sistema de alerta temprana anteriormente estaba diseñado por medio de una regleta de madera que mantenía colores y numeraciones, donde la población tenía que ir a hacer lo que era la medición y visualizar propiamente en el lugar a qué nivel se encontraba el río.
Por lo que necesitábamos un sistema de alerta en la zona para poderle comunicar a la ciudadanía los distintos eventos.
Debido al aumento de los riesgos que se mantienen en las comunidades que viven cercanas a los ríos, se llevó a la necesidad de tener un sistema muy puntual y muy eficiente que pudiésemos, como Sistema Nacional de Protección Civil, brindarles alerta a la comunidad. Este sistema hoy en día se ha modernizado y se ha llevado a un punto tecnológico que anteriormente no se tenía.
Para esto utilizamos las tecnologías de Amazon Web Service y sensores IoT basados en comunicaciones LoRaWAN para tener la información en tiempo real y poder dar lo más pronto posible una alerta. De los sensores estamos obteniendo la data en tiempo real en la nube, lo cual es procesada y mostrada en los distintos tableros de control para que el SINAPROC pueda ver el estado actual del río y también a su vez tiene las alertas automáticas cuando algún evento esté pasando.
Esto nos permite a nosotros hacer un aviso efectivo y eficiente a las comunidades, ya que los sensores nos permiten tener información de nivel del río en tiempo real, como igualmente nos da una estadística en el momento de que se pudiera generar un tipo de inundación en esta comunidad. Panamá, al implementar este tipo de tecnología, se coloca a la vanguardia de los sistemas de alerta temprana.
Ahora hemos visto el poder de una plataforma que junta datos de diferentes fuentes en el de Celo Verde y cómo es el poder de usar sensores como Internet de las Cosas para también colectar datos. Por favor, cuéntanos un poquito profundizar un poquito sobre el video.
Bien, buenas tardes, muchísimas gracias. Definitivamente Panamá, aunque somos un país pequeño, muy pequeño en comparación con todo el resto de Latinoamérica, no estamos exentos de la ocurrencia de desastres. Principalmente nos vemos influenciados o afectados todos los años por inundaciones que representan pues, pérdidas tanto económicas, vidas humanas y demás. Esta tecnología nos ha permitido dar un gran paso. Es una tecnología de fácil integración con tecnologías que ya existen o que son utilizadas dentro del Centro de Operaciones de Emergencia Nacional y que nos permiten, como lo mencionábamos, poder tener acceso a la información a través de una nube, a través de datos que se generan en tiempo real de manera inmediata y que facilitan y disminuyen los tiempos de tomas de decisiones en temas tan sensitivos como lo que es la evacuación de comunidades, lo que es la alerta a las comunidades, la toma de decisiones o las recomendaciones que se deben hacer a nuestras autoridades, siendo así Panamá un país pionero en la implementación de este tipo de tecnología de Amazon Web Service en toda Latinoamérica.
Sí, y es algo que hemos hablado en esos días que es muy importante para otros países también en la región. Now we're going to start a question and answer, and then don't worry, there'll be an opportunity for you all to ask questions of our distinguished panelists as well. So, Rodrigo, share with us how science-based solutions and technology can be combined to help the public sector.
Yeah, so the integration of science-based solutions and cloud technology empowers governments to make data-driven, scalable, and cost-effective decision-making, and also enabling rapid response against extreme events or to solve challenges like wildfires, for example, in Brazil, or floods in Panama, right? I'll just list some opportunities of merging science-based technologies and cloud technologies, but the list is not exhaustive, of course, but just would like to highlight some points. First, it provides informed decision-making because you can upload all your data to the cloud and also process the data online, and then the response will be really fast if you're using such an infrastructure, right? And also the costs involved are pretty much reduced. You don't need to invest in premises to keep large facilities and things like that. So it could be something, a game changer in poor countries like, for example, Brazil and other countries in South America. So this partnership is really important between scientific institutions there, like we are, and the partnership we have with AWS to provide access to the cloud technology and being able to scale. That would be the third point. The fourth point I'd like to highlight. So scalability covering large regions, for example, as the Brazilian savanna, to help us to prevent fire spread in that very important biome. But after all, of course, we are concerned about preserving natural environments, but we are talking about lives, right, in the end.
Yes, absolutely. And really, I think your Celo Verde shows the power, the collaboration between academia and the private sector in coming up with a solution that governments can use to be able to make better data-driven and science-based decisions.
Absolutely.
Malizia, en el caso de Panamá, Cuéntanos un poco cómo la tecnología ha apoyado con la preparación y respuesta, cómo era antes y cómo es ahora.
Bien, en efecto, los desastres evolucionan, no solamente la tecnología. Al igual que la tecnología cada día va evolucionando, tenemos nuevas herramientas, tenemos nuevas tecnologías, hablamos de inteligencia artificial todos estos días, los desastres también evolucionan. Cada día son más severos debido a procesos del cambio climático, debido a la variabilidad climática. Nos enfrentamos a mayores retos, a mayores riesgos, a mayores amenazas. Comunidades que anteriormente no eran vulnerables, ahora sí lo son, debido a que son más agresivos o más severos el impacto de la naturaleza que se tiene en ellas. Y generalmente son comunidades que están en condiciones de escasos recursos económicos, y esto representa una mayor vulnerabilidad para la población porque obviamente no pueden adquirir o construir metodologías o herramientas que les permitan enfrentarse como infraestructuras y demás de manera adecuada al impacto de los desastres. ¿Qué ha hecho la tecnología ahora? Anteriormente hablábamos de regletas, sistemas muy rudimentarios, reglas de madera construidas con códigos de colores, con numeración, que se hacía la medición pero de manera manual. La población tenía que ir a acercarse al río, muchas veces el río estaba acrecentado, muchas veces habían tormentas eléctricas, muchas veces ya el río estaba desbordado, o sea que ya era una condición de riesgo para la población y aún así ellos iban, realizaban las mediciones y tenían que enviar esa información al centro de operaciones de emergencia. Hablamos de una exposición de una vida, hablamos de que si se caían los sistemas de comunicaciones, las redes de internet y demás, no había ese proceso de comunicación en un desastre de gran magnitud, se veía interrumpida y la información demoraba demasiado en llegar al centro de operaciones de emergencia, haciendo que la toma de decisiones fuese no en tiempos oportunos. Al implementar este tipo de tecnología, como la que nos proporciona Amazon Web Service, hoy en día podemos hablar de que tenemos datos en tiempo real, sin necesidad de exponer a la población, sin necesidad de que tengamos que esperar un determinado tiempo para poder acceder a ella. En nuestra sala de monitoreo, dentro del centro de operaciones de emergencia, hay monitoreo las 24 personal que hace este monitoreo las 24 horas del día y que tiene acceso a esta información de manera inmediata. El programa emite una alerta cuando los niveles se ven ya fuera de lo normal. El mismo programa de manera automática emite alertas que nuestros oficiales de operaciones, ellos están al pendiente. Obviamente hay otras tecnologías que también van de la mano con este proceso y lo cual nos permite la toma de decisiones oportunas, tanto a nivel de los jefes de Estado como también para la población, porque se manejan las alertas que van definidas para lo que es la toma de decisiones y la que va entonces para la población y las acciones que éstas tienen que desarrollar. Al implementar esta tecnología, Panamá, en conjunto con otras que llevamos, hemos reducido también el consumo de papel en un 85%, lo cual se traduce y que ya fuimos reconocidos ante la ONU como uno de los países que realiza gestión integral de riesgo de desastres verde, producto de que estamos contribuyendo con lo que es el ambiente y a la vez no descuidamos lo que son nuestras labores para lo que es la reducción de riesgos en las comunidades.
Y me estaba también contando, agregando que estos datos también otros entes de gobierno también se pueden usar.
Sí, por supuesto. Al ser una tecnología de fácil acceso y también una tecnología que se puede integrar de manera o articular de manera muy simple con otras tecnologías existentes, no solamente en nuestra institución, nosotros también generamos datos para otras entidades como el Instituto de Meteorología de Panamá, que realizamos un trabajo en conjunto y que es sumamente importante para la población y para nuestros tomadores de decisiones a la hora de que se brinden estos servicios. Entonces, este tipo de herramientas disminuyen tiempos, facilitan el trabajo, reducimos y colaboramos con el ambiente en el tema de hacer la gestión de riesgo verde y contribuimos también a que la población tenga una mejor respuesta, más eficiente y más eficaz.
Muchas gracias. Ahora I'm going to ask the next question to Camila Saad. So Camila, I know that you're working with a lot of different countries and a lot of different agencies across Latin America. Share today a little bit about how AWS technology is helping in areas outside of flooding and open source platforms like Celo Verde.
Absolutely. Thank you, Abby. Well, the United Nations Office of Disaster Risk Reduction guides organizations to follow a multi-disaster early warning system approach. What does this mean? Early warning systems that follow a multi-hazard disaster approach take into consideration that disasters like wildfires, floodings, earthquakes occur alone, simultaneously, in sequence, and cumulative over time. Based on this guidance in AWS and the Disaster Preparedness and Response Program, we work with organizations like SINAPROC to develop systems that integrate different disasters. We just heard about flooding, also a little bit about wildfires. Let me tell you about earthquakes. Early earthquakes warning systems historically have been very expensive, in particular for emerging economies or emerging countries that don't have sometimes the budgets that can afford this type of assistance. This is why we're working with a partner called Grillo. They developed a sensor that costs less than $500. Just to give you a comparison, historically, seismometers, that are these devices that measure or detect shakes, can cost around $10,000. This allows governments to deploy inexpensive sensors in a high-density network. This significantly reduces not only, of course, cost, but also the time of detection, allowing and enabling organizations like SINAPROC alert citizens in a much faster way so people can evacuate or find shelter seconds before the shake starts. In wildfires, to complement what Rodrigo was saying, satellite imagery can detect a wildfire in a matter of days or hours. Wildfire cameras can detect it in a matter of hours. Sensors, and this is the newest technology, allows what we call ultra-early detection of wildfires. These sensors, imagine they are like a very intelligent nose in a forest that can detect changes not only in temperature or humidity, but also in different gases in the atmosphere. This, of course, allows to firefighters, emergency agencies in the first line of response to detect fires in a matter of minutes and not wait until hours or days have passed when we all know sometimes it's too late. Specifically for earthquakes, we have, for the last 2 years, worked with organizations in countries that are highly seismic in Latin America and the Caribbean, like Chile, Mexico, Haiti, Puerto Rico. We're actually currently right now starting or kicking off a pilot in Ecuador, another highly seismic country in the Andean region. For wildfires, specifically for these IoT sensors, the ones that I mentioned that are like a big nose, we are planning to kick off this project at the beginning of next year in Tierra del Fuego, Argentina. Our North Star in the Disaster Preparedness and Response Program is to work with organizations in the government, researchers, institutions, to integrate a system, a multi-disaster system, that ultimately enables these organizations to serve better communities that are at risk.
And if you wouldn't mind, also share a little bit about the network of Red Labot, because I think it's important as well as it ties in with the open data that's available on AWS from NASA and from NOAA, and the partnership that we have with NASA.
Absolutely. One of the opportunities that we saw and we are seeing is how we can partner with education institutions, in particularly researchers in the disaster risk reduction space, to enable them, to give them technology and to give them data to accelerate the research. We know that Latin America is the second region, disaster-prone area region in the world after Asia Pacific. This is why it's so important for us to partner with institutions, like I said, researchers, to give them the tools to accelerate this research. Particularly, we have partnered with the NASA Disaster Response Office for Latin America, also with Esri, an AWS partner, to provide a series of trainings and also tools to, as I mentioned, catalyze the research for these insights that come out of institutions or universities to feed into governments that need to make decisions based on data that is not only more accurate, but also is delivered in a faster way.
Thank you, thank you. Now I think we have time, if there's any questions from you all in the audience, to ask of our experts.